Hey guys, so in this video we're going to go over IXL section K.3 underneath the Algebra 2 class. The topic is multiplying polynomials. So when multiplying polynomials, it's good to understand that variables that are the same can multiply with other variables, and all it does is change the count of how many of those variables you have multiplying, which means that your exponent's going to be changed. Remember, exponents are just a count of multiplication. And your numbers, well, you multiply those just like you're used to. So, for example, we look at this, and our numbers, we'll go ahead and start with those. 9 and 8. Those are just going to multiply together. We can also call those our coefficients, and our coefficients will multiply together. So 9 times 8, that is going to make 72. And notice this was a negative 8, so there will be a negative sign in front. And now I have a c times a c squared. Now remember, c squared actually means c times c. So if I were to write this out, I would have a c times a c times a c. I would have 3 c's multiplying because I got 1 from right here and 2 from right there. Meaning that I now have 3 c's multiplying together. And that's fine and dandy, but the thing is, we have a better way of notating this. Specifically, we actually use exponents to condense this down. So we can actually write this as negative 72, notice that didn't change, but rather my c's I can write as c cubed, or c to the power of 3. Why did I write it as c to the power of 3? Well, because I had 3 c's multiplying right here. This number is just a way of keeping track of multiplication. Hence, you can just think of these two numbers as being added together. So our final answer is going to be, how do I get the writing thing? No. Ugh, I can't write it? Come on. I love that feature. No, I guess not. Okay. So, our answer is going to be negative 72 c to the power of 3. Cool. Okay. So, again, can I write right there? No, I can't write right there. Alright, so same deal here, except now when we have a number that's multiplying outside the parentheses, remember we have to distribute this. So this 6 is going to multiply first the negative 3c squared, and then it's going to multiply the 2c. So this will equal 6 times negative 3 will be negative 18. And then c squared, notice there's just the c squared. I didn't have any c's with my 6, so I just have c squared right there. No additional c's being multiplied. And then we're going to do the same thing, but now with 2c. So 6 will now multiply 2c, and we will get plus 12. 6 times 2 is 12. And then a c, because c was still there, didn't go anywhere, and we're not multiplying any additional c's. So our final answer is going to be negative 18 c squared plus 12c. Nope, that's all superscript. There we go, plus 12c, and that should be good. Cool. Okay, so I'm going to show you another way to think about this, and this is something you've probably seen before. We call it the box method, and how we use it is we look at our two numbers that are multiplying, and then for each term in those multipliers, we're going to make a space on a box. So notice we have a monomial and a monomial. So we have a negative 5b right there, and we have a 8b that can go right here. Now, at this stage, it may seem pointless to create the box like this. But you're going to see that as we go to larger and larger polynomials, that this box actually really helps us keep things organized, and it also shows our work very clearly. So now I'm just going to multiply these together. Remember, 5 times 8. My numbers multiply each other, and I will get negative 40. And then b times b, well, now I have two b's multiplying, or b squared. So my final answer is going to be negative 40 b squared. Just like that. Okay, let's go ahead and let's use that box method again. And remember, when I set up my box, I'm going to create a space for each term in my multipliers. So when I look at a squared, I see there's only one term, so I'm just going to create a side like this with only one space. And then I look at this multiplier and I see two terms in here. So I'm going to create a space right there and a space right there. So all in all, my box is going to look like this. And you notice this can help you make predictions about the kind of term you're going to come out with. Right? We have two boxes, so it's very likely we're going to come out with a binomial. So we have a squared and negative 2a squared and 2a. Now we can go ahead and multiply them. There's no coefficient here, or we can treat it as though there's a 1. So 1 times negative 2 would still just be negative 2. And a squared times a squared, well, we got to ask, how many a's do we have multiplying? Well, we have 4 of them, a squared and a squared. And now we will total them up, and we will say that we have 4 a's being multiplied, or a to the 4th power. Again, we have a squared times 2a, so the 2 times the 1 just makes a 2. And a squared times a is going to make a cubed. I like writing my answer in here much better. Plus 2a, but I guess we'll have to make it do. Cool. So that is my answer. Nice, great. So now we have some binomials times some binomials. Now, why is this good? Because you can really see the box method come into, full use, right? You're going to see why it's helpful to make this box. So again, we have a binomial and a binomial. So I should have a box with two spaces on one side, and then two spaces on the other side, right? It's a binomial and a binomial. So now I'll go ahead and finish drawing my box. And I'll place these terms 2c minus 4 and 4c and 2. Now before I go ahead and calculate this, you may be thinking, well, what happens if I accidentally switch up the terms? Meaning, what if I accidentally did 4c plus 2 and 2c minus 4? Right? What if I accidentally did that? Well, I want to encourage you to work that out, and I want you to encourage you to play with the different ways that you could maybe set up this box and see which ways are okay and which ways are not okay. But I will go ahead and tell you that it is okay to do this as well, right? This is an okay method to do. The biggest caveat to it is that you keep your polynomials together. So notice my 4c and my 2 didn't get split up. They are still on the same side. And my 2c and my minus 4, they are still on the same side. So this is perfectly okay. So I'll go ahead. Now these both should give me the same answer, but I'm going to work out the one on the left. And so 2 times 4 will be 8. C times c will be c squared. And 2c times 2 will be 4c. And 4c times negative 4 will be negative 16c. And negative 4 times 2 will be negative 8. We'll go ahead, write our answer in, and we have... Now, notice, when I go to write my answer, I do need to do some simplification here, because I'm going to get out 8c squared plus 4c, just all the terms inside of here, minus 16c minus 8. And if you know like terms, you're going to look at this, you're going to say, well, these are like terms, right? It's a c and a c. So those can be combined together, which would ultimately give me something like 8c squared. And then 4c and negative 16c, well, that's just going to make a negative 12c and a minus 8. The minus 8 just came down and was tacked on. And so that is my final answer. Now, if you wrote this, right, if you wrote this thing right here as your final answer, that actually this would be considered incorrect because it is not fully simplified. You do need to simplify your answer. So we have 8c squared and minus 12c and minus 8. And that should do it right there. Okay. All right, so here we have a perfect square. It's called a perfect square because it just has a 2 right up here. Now, how do we multiply this? Or in particular, especially if you're thinking about this with box method, how would I set this up? Because I only really see one polynomial. Now, the trick here is this power right here, right? This technically is just a k plus 2 multiplied 2 times. So I could write it with a power of 2, or I could write another k plus 2. And once you write it like this, it finally becomes clear where your second polynomial is. That's your first polynomial right there, and that's your second polynomial right there. So now you can go ahead and set up your lovely box method. K and 2, K and 2, and now we go ahead and multiply. K times K is going to be K squared. This will be 2K, this will be 2K, and 2 times 2 will be 4. So out of here we will get a K squared. And now before I write my 2K, I notice that I have a 2K and a 2K. Those are like terms, they can be added. So I'll have plus 4K. And then my 4 just comes on down, making that my final simplified answer. So K squared plus 4K plus 4. Cool. Alright, so another binomial, or another binomial times a binomial. So remember, we're going to look for our 2 polynomials. We will set up a box to fit those polynomials. Notice it's a binomial and a binomial, so 2 places on each side. And now we'll go ahead and write my polynomials on each side. Now, it's always good to notice patterns, and you might want to immediately notice that these are the same, it's just that one of them has a negative. Pay attention to that and see how it turns out. So 3b times 3b will be a 9b squared. 3b times 1 will be 3b. And 3b times negative 1 will be negative 3b. And negative 1 times 1 will be a negative 1. Okay, now let's go ahead and write our final answer. We will pull everything out of there, and if we can combine like terms, we will. We will have a 9b squared. And then I have a 3b, but I also have a negative 3b. And so those are both opposites of each other, perfect opposites, so they're actually going to cancel to 0. So these will cancel out, and I'll be left with just my negative 1. And now the pattern may be a little bit hard to see with this one, but you can actually notice that these are both perfect squares. Ah, man, can't write right there. Oh, there we go. These are both perfect squares, right? 9 is a perfect square, and so is b squared, and so is the 1. So this is actually a pattern that we see reoccur a lot, and we actually come up with a name for it just because it reoccurs so much. We're actually going to end up calling this a difference of perfect squares. And you can see why that would kind of make sense, because like we noted, they're both perfect squares. Oh, don't judge me, I'm probably going to spell this wrong. Difference of perfect squares. Okay? Right, why do we call it a difference of perfect squares? Well, because that's one perfect square, and that is a second perfect square, and that is the difference, or the subtraction, right between them. So, good little pattern to notice. If you don't notice it, you will get by just fine, but it will help you out to keep this pattern in mind. Alright, so our final answer is 9b squared minus 1. Alright, so another set of binomials. I'm immediately setting up my box with two blanks on each side because I have a binomial and a binomial. So this will be 3x minus 3. This will be x and 3. We can now go ahead and multiply. So we have 3x times x. That'll be 3x squared. And 3x times 3 will be 9x. Negative 3 times x will be negative 3x. Negative 3 times 3 will be negative 9. Okay, so remember we do want to go ahead and add these together. So we will get a 3x squared. That is my only x squared term. I have a 9x, and I also have a minus 3x. So those are like terms. I'll combine them together to make a 6x and a minus 9. Alright, and that is my final answer. So we'll go ahead and enter it in. 3x squared plus 6x minus 9. Beautiful. Great. Another perfect square. Right? And we actually call this a binomial squared. Right? Kind of makes sense why we do, because it's a binomial and it's being squared. But remember, this can be written as 2h minus 2 with a 2h minus 2. Right? Two of these terms being multiplied together. And so we can now write this as a box that will look like this. And so as I write this, there's another really good pattern to notice here. And it's anytime we have a binomial squared, we're actually going to notice that a very predictable pattern comes out of here. And I'll even show you the equation to that pattern. So we go ahead and combine our like terms. We have a 4h squared, a minus h, and a plus 4. Notice I just combined those two like terms. Alright, so what the pattern is that anytime we have a binomial, right, just anything a plus b squared, what we're going to get out is going to be a squared plus 2 times a times b plus b squared. Now again, this is one of those patterns that it will help you out to recognize it, but if you don't, you will get by just fine. And how can we recognize this pattern? Well, we see that a would have been 2h. So 2h squared, well, 2 squared would be 4. And then h squared would be h squared. And then we have a 2ab in the middle, so 2h was a, so we would have 2 times 2h, which would be a 4h. And then b is technically our negative 2. So 4h times negative 2 would actually end up making negative h. So I know that there was a couple calculations there, but you see that 2ab, right, where this was a and this was b, equaled negative h. And then our final one is b squared. If b is negative 2 squared would just be 4. So again, like I said, it's a good pattern to know, but you see that you are still able to calculate the answer just fine. So our final answer is going to be 4h squared minus 8h and plus 4. Okay, so I do want to go over trinomials with you. So I'm going to go a little bit faster over these, and you're probably getting the hang of them by now. So I'm setting up my box method, 2r4, 2r minus 4, and I multiply these together. I get 4r squared. I get negative 8r, and then I get 8r, and then I get negative 16. And again, remember, notice this is a difference of perfect squares. So these guys are just going to cancel out, giving me 4r squared minus 16. So 4r squared and minus 16. Alright, we're going to have some trinomials? Yes, nice, here we go. So, like I was saying, the great thing about box method is it's still going to work. But we have to remember that we made a space for each term in our polynomial. So I see only one term in my first polynomial, so I make one space right there. But now I see 3 terms in my other polynomial, so I make 1, 2, 3. I go ahead, connect my box, but hopefully make it a little bit nicer than I did. And then you can write your terms in negative 3s squared, 3s squared, 4s minus 4. We write our terms in, and then we can go ahead and multiply. So we get negative 9s cubed. Notice we had, oh, I'm sorry, not cubed, to the power of 4, negative 4s to the 4th. And then we have negative 3s squared times 4s. That's going to be negative 12s cubed. And then we have negative 3s squared times negative 4. That will be positive 12s squared. And so these are our 3 terms. We can look to combine them, but we don't see any like terms in there. So our final answer is written just like this, with all of our terms laid out, none of them combined together, because we don't have any like terms in here. And so that's our final answer. So we have negative 9s to the power of 4 minus 12s to the power of 3 plus 12s to the power of 2. Okay, just like that. Ooh, nice. Another good one. we'll go ahead and we'll finish with this last one because I know the video is getting long. So as long as you can remember to make a space for each term, you're going to be fine, right? And so as I make this box, notice I made 3 spaces on top and 2 spaces on the side because I have a binomial and a trinomial, right? 2 terms, 3 terms, I account for it on both sides. So now I'll go ahead and write my terms in, and I have my terms over here. And so now that all my terms are put in there, well, this is basically the same as what we did before. There's just more work that needs to be done. We need to multiply each box, and then we need to see if we can combine any like terms. So I have 2k times negative 2k squared, which will be negative 4k cubed. 2k times negative 3k will be negative 6k squared. 2k times negative 1 will be negative 2k. Negative 2k squared times 2 will be negative 4k squared. And then 2 times negative 3k will be negative 6k. And 2 times negative 1 will be negative 2. Alright, so that is all the math done right there, but we do need to see if we can simplify and combine any like terms. So we'll go ahead and I see my k cubed, and I don't see any other k cubes there, so I'll just write negative 4k cubed. Oh, what are you doing? Stop. My cat's trying to... Sorry. Alright, so... Oh gosh, that's terrible. It's my cat's fault. So this will become, we're just going to erase this. This will become negative 4k cubed, and then negative 4k squared and negative 6k squared. So notice I'm just combining my like terms. I'm then going to have negative 10k squared and negative 6k and negative 2k. That will make negative 8k and minus 2. So that's my final answer. Notice I got 4 terms out of here. I did have 6 spaces, but remember, these 2 combined together and these 2 combined together. So my final answer, negative 4k cubed minus 10k squared minus 8k minus 2. Okay, and we'll go ahead, we will call it a wrap. We'll see you guys later.